Dear friends, let us see lecture number 24. See, let us consider I is equal to 0 to pi by 2 dx over 4 sine square x plus 5 cos square x. Now, dear friends, let us come on for indefinite integration. I is equal to, whenever dx over a sine square x plus b cos square x is given, I is equal to a sine square x plus b cos square x is given, then there is a special procedure to integrate it. See, here it is also a revision of indefinite integration. See, then first step, divide numerator and denominator quantity by cos square x. Next step, convert denominator quantity in terms of 10. Third one, take 10 is equal to t. Clear? Here variable x is given, they can give x, 2x, x by 2, 4x, whatever may be. But here numerator is 1. Clear? Now see, so before solving this definite integral, let us see here. I is equal to dx over 2 sine square x plus 3 cos square x. Suppose here a is equal to 2, b is equal to 3. So divide numerator and denominator quantity by cos square x. So here we get sec square x dx. Here we get 2 tan square x plus 3. Now tan x is equal to t. Suppose tan x is equal to t. So it comes out sec square x dx is equal to dt. And therefore I is equal to dt over 2t square plus 3. 2 taken common. Dt over t square plus whole root 3 by 2 whole square. That is 1 by a, 1 by root 3 root 2 tan inverse t by root 3 over root 2 plus c. That is equal to root 2 by root 3 tan inverse root 2x root 2t. Tan inverse root 2 t by root 3 plus c. Now what is t? T is equal to tan x. So that comes out root 2 by root 3 tan inverse root 2 tan x by root 3 plus c. This is the answer. Whenever numerator is 1 and denominator quantity is combination of sin square and cos square x. આ સમય આપેલું હોય છેદમાં sin square x અને cos square x નું કોમ્બિનેશન આપેલું હોય તો અંશ અને છેદને cos square x વડે ભાગો. છેદને 10 માં કન્વર્ટ કરો. પછી 10 is equal to t આદેશ લેવાથી થાય. અને એ ટાઈપનું આપણે એક એક્ઝામ્પલ જોઈ લીધો. બરાબર? So this type of combination is given to us, then you can solve any one of them. So let us see this example. 0 to pi by 2 dx over 4 sine square x plus 5 cos square x d. Now you can see that here combination of sine square and cos square is given to us. So divide numerator and denominator quantity by cos square x. So this comes out sec square x dx for tan square x plus 5. Here automatically it is in terms of that thing. 1 minute. They can give this example in this way also. Dx over 4 sine square x plus phi only. Clear? Here is a combination of sine square and cos square. Only combination of sine square x is given. Because in this formula, they can take any value of a and b. A and b both are belongs to R. They can take either one of them as a 0 also. No problem. So here also we have to divide by cos square. So it comes out sec square x dx over 4 plus 5 sec square x. Now see this second step. Convert denominator quantity in terms of tan. So that is equal to 0 to pi by 2 sec square x dx 4 plus 5 into 1 plus tan square x. So 0 to pi by 2 sec square x dx over 4 plus 5 9 plus 5 tan square x. Now you can take tan x is equal to t. Clear? So I am leaving this one for you. Let us see for you this one. Now let us try to solve this sum. Suppose tan x is equal to t, and therefore sec square x dx comes out dt. Clear? So here not pi by 2 but pi by 4. Sorry, pi by 4. Pi by 4. 0 to pi by 4. Pi by 4. Pi by 4. Now x tends to 0 implies t tends to 0. And x tends to pi by 4 implies t tends to 1. So I is equal to 0 to 1 dt over 4t square plus pi. 4 is outside. 1 by 4, 0 to 1 dt over t square plus, can I write root 5 by 2 whole square? Yes. That is equal to 1 by 4, 1 by a, 1 by a, tan inverse t by root 5 by 2. Put upper limit and lower limit. That comes out 1 by 2 root 5. Clear? This combination or simplification of this one is 1 by 2 root 5. Take tan inverse t is equal to first of all 1. So tan inverse 2 by root 5 minus 0. That is equal to 1 by 2 root 5 tan inverse 2 by root 5. This is the answer. So let us leave for you. Next sum. I is equal to zero to pi by 2 sin x into cos x over cos square x plus 3 cos x plus 2 into dx. This one is given to us. In this case, t cos x cos square x is equal to t. But see, here directly you can take cos x is equal to t also. Cos x is equal to t because its derivative is given here. My sin x derivative is given to us. So directly you can take cos x is equal to t for this sum. Now 0 to pi by 2. 0 to pi by 2 dx over 3 plus 2 sin x plus cos x. Before that one, let us see one important pattern of indefinite integration also. Integral dx upon a sin x plus b cos x plus c, where a, b, c belongs to R, but a and b cannot be 0 together. In that case, what we have to do? See, here they can take x by 2 also, they can take 2x also, they can take 3x also, they can take any variable here. Now, then what we have to suppose? Tan of, see, let us consider in that way integral. Dx over a sin some angle, b cos some angle plus c. Clear? Then tan some angle by 2 is equal to t. This is the hint. Using this concept, we can solve this type of integration. See, if we compare with the first one, here it is combination of sine square and cos square x is given. Here it is just combination of sine and cos is given. In that case, tan of something, that is equal to t. In place of, they can take x by 2, they can take 2x, they can take 3x, they can take any one, any angle. But whatever may be angle is given here, whatever may be angle is given here, suppose tan of that angle by 2 is equal to t. Clear? See, before solving this example, I would like to solve indefinite integral. See, 0 integral dx over, consider 2 consider 3 plus 2 sin x plus cos x. Yes, just this one is just previous sum. Yes or no? Yeah. This one. Limit is given 0 to pi by 2. Let us see that thing together, no problem. 0 to 2. 0 to pi by 2, not 2. 0 to pi by 2. See, what is the angle is given here? X. So what we have to suppose? Tan x by 2 is equal to t. Clear? Now, differentiate it. 1 by 2 sec square x by 2 into dx is equal to dt. That we know. And therefore, dx is equal to 2 dt over sec square x by 2. Can I write that is equal to 1 plus tan square x by 2? Yes. That is equal to 2 dt over 1 plus t square. Clear? Now let us see. We know that cos 2x in terms of tan, 1 minus tan square x over 1 plus tan square x. Sin 2x in terms of tan, 2 tan x over 1 plus tan square x. Clear? Now see. Here angle 2x is there, so its half part is here. Same way here 2x is there, its half angle is here. Clear? So if we wish to make a formula of cos x, then half of this one. So half of this one. 1 minus tan square x by 2 over 1 plus tan square x by 2. In case of sin x, 2 tan x by 2 over 1 plus tan square x by 2. Clear? So use this pattern here. Now, also sin x is equal to 2 tan x by 2 over 1 plus tan square x by 2. That is equal to 2t over 1 plus t square. Cos x is equal to 1 minus tan square x by 2 over 1 plus tan square x by 2. That is equal to 1 minus t square over 1 plus t square. It is a special substitution. Clear? Now see here. Now same time we have to change the limit also. See here. X tends to 0 implies t tends to. Take x is equal to 0 here. Tan 0 is 0. And x tends to pi by 2 implies t tends to. Take x is equal to pi by 2 here. So what you get? Pi by 4, and tan pi by 4 comes out 1. Yeah. In this way, we have to see. And therefore, what is I? 0 to 1. See? 0 to pi by 2, that is 0 to 1. Now, what is dx? Dx is equal to this thing. 2 dt over 1 plus t square in denominator quantity. 3 plus 2 sin x. What is sin x? 2t over 1 plus t square plus cos x plus cos x. What is cos x? 1 minus t square over 1 plus t square. Clear? Now see, dear friend, this one is of the 4 marks example. 4 mark માટે છે મિત્રો આ 0 to 1 2 dt take 1 plus t square LCM. એને લસા લઈ લઈએ તો 3 plus 3t square plus 4t plus 1 minus t square. 0 to 1 2 dt 3t square minus t square 2t square plus 4t plus 4. 2 to cancel. 0 to 1 dt t square plus 2t plus 2. Yes or no? Yes. So that is equal to 0 to 1 dt over. Can I write here t square plus 2t plus 1 plus 1? Perfect square, we have to arrange it. 0 to 1 dt over t plus 1 whole square plus 1 square. And that is equal to tan inverse x by a, t plus 1 by 1, 0 to 1. So that is equal to tan inverse 2 minus tan inverse 1, because t is equal to 0 than this one. And we know that the formula, tan inverse x minus y over 1 plus xy. So that comes out tan inverse 1 by 3. This is the answer in case of this one. So any combination is given to us, we can solve it. Now see, same way, one of the example is here, 0 to pi by 2 cos x over 1 plus cos x plus sin x into t. Of course, in denominator quantity, that part is given to us. In combination of sin and cos is given to us. In numerator, cos x is given to us. Limit 0 to pi by 2. Angle is x here. So take tan x by 2 is equal to t. Rest of part for you. Clear? Same way, one more example. 0 to pi by 2 cos x over 3 cos x plus sin x into dx. Same way, take that is equal to t. Clear? Now 0 to pi by 2 dx over 1 minus 2 sin x. Here also just combination of sin. So here also take tan x by 2 is equal to t. Clear? Now 0 to 1 2x plus 3 over 5x square plus 1 dx. Numerator is linear, denominator quantity is quadratic. Arrange derivative here. 0 to 1 x cube under root 1 plus 3x raised to 4 dx. See, take x raised to 4 is equal to t. Why? Because here x cube is there. So x cube into dx comes out in terms of dt. So that thing is there. 0 to 1 x under root of 1 minus x square over 1 plus x square dx. Now see here. In this example, what we have to see? We have to take x square is equal to cos 2 theta. Let us see next page. 0 to 1 x under root 1 minus x square over 1 plus x square into dx. 1 minute. Before this sum, let us see I is equal to 0 to 1 under root 1 minus x upon 1 plus x dx. Can I write here 0 to 1 minus x over root 1 plus x? Now, a typical sum, very important sum. All of you, please see here, please see here. This step is important. Rationalize numerator. How we get this thing? Not clear? Let me see here. Root 1 minus x, root 1 plus x, root 1 minus x, root 1 minus x dx. So that is equal to 0 to 1, root a into root a, that is 1 minus x over root 1 minus x squared dx. Then what? Let us see on next page, this one. Right now solve this one. So that is equal to 0 to 1, 1 over under root 1 minus x square minus x over under root of 1 minus x square into dx. Now it is easy to convert 0 to 1 under root 1 minus x square dx into dx. Please see here, 1 by 2, 1 minus x square raised to minus half into minus 2x dx. Why I am arranging in this way? Because of derivative of 1 minus x square can be arranged here. This is the reason why I am taking in this way. So 0 to 1 under root 1 minus x square dx, 1 by 2, 0 to 1, 1 minus x square raised to minus half into d by dx of 1 minus x square into dx. So that is equal to, we know that integral is sine inverse x, 0 to 1 plus 1 by 2. What is the integral of this one? 1 minus x square raised to 1 by 2 over 1 by 2, 0 to 1. So sine inverse 1 is pi by 2 minus sine inverse 0 is 0. Half cancel. What we get? Under root 1 minus x square, 0 to 1. So pi by 2, if I take 1, then that comes out 0. So 1 plus 0 minus 1. So it comes out pi by 2 minus 1. Clear? Of course, this one is also important sum. Sorry? Important sum. Now let us see that example. I is equal to 0 to 1 x under root 1 minus x square plus 1 plus x square dx. Can we solve it like a previous way? Yes, we can solve it. How? See here. 0 to 1 under root of 1 minus x square under root of 1 plus x square under root of 1 minus x square. We are rationalizing numerator. અંશની કરણી લઈએ છીએ આપણે here. So that is equal to 0 to 1, 1 minus x square over under root 1 minus x raised to 4 into, can I write x dx? Take x together with dx. Yes. Now once again, what we have to do? Suppose x square is equal to t. Then that comes out 2x dx is equal to dt. And therefore, x dx is equal to 1 by 2 dt. Same time change the limit also. Also x tends to 0 implies t tends to 0. And x tends to 1 implies t tends to 1. So what is I? And therefore, I is equal to 0 to 1, 0 to 1, 1 minus t over under root 1 minus t square into half dt. So that is equal to half 0 to 1, 1 minus t over under root 1 minus t square dt. Now this one is previous example, like a C. According to this only half is there. So rest of part I am leaving for you. So that type of example converted into this pattern also. Now let us see very, very easy example. 0 to pi by 2 under root 10x plus under root cot x dx. Under root 10x plus under root cot x dx. In indefinite integral, we already seen this example. Separately, we seen root 10x dx, root cot x dx. Now you can take root 10x plus or minus root cot x. Any one of them you can take it. Here root 10x plus cot x is given to us. Very special way to solve it. Clear? See here. Call this one as I. 0 to pi by 2. Convert into sine cos. Here. Now take LCM. 0 to pi by 2. Can I write here sin x plus cos x? Or can I write under root sin x into cos x? dx. Now see, 0 to pi by 2 multiplied and divided by root 2. Why? Let's see here. 2 sin x into cos x to get that thing. Now see, sin x plus cos x is derivative of sin x minus cos x. Yes or no? Differentiation of sin x is cos x, minus what? Differentiation of cos x is minus sin x. So that is equal to sin x plus cos x. Is a derivative of sin x minus cos x. So try to arrange denominator quantity in terms of sin x minus cos x. How? See here. Root 2, take it outside, 0 to pi by 2. Can I write here 1 minus 2 sin x into cos x? Yes, we can write it. Numerator sin x plus cos x. Clear? Now see, what we have to do? That is equal to root 2, 0 to pi by 2. Sin x plus cos x over under root 1 minus sin x minus cos x whole square into dx. Clear? Now take sin x minus cos x is equal to t. And therefore cos x plus sin x into dx is equal to dt. Also change the limit. X tends to 0, put here 0, sin 0 is 0, cos 0 is minus 1, t tends to minus 1. And x tends to pi by 2 implies x tends to sin pi by 2, 1, t tends to 1. So what is I? I is equal to 0 to pi by 2, so minus 1 to 1, minus 1 to 1, root 2 outside. dt over under root 1 minus t square. See, very easy. So that is equal to root 2 sin inverse t minus 1 to 1. Root 2 sin inverse 1 minus sin inverse minus 1. Root 2 sin is inverse is even function. Sorry, sin inverse minus x is equal to minus sin inverse x. So that comes out to sin inverse 1. 2 sin inverse 1. And that is equal to 2 root 2 into pi by 2. Why? Because sin inverse 1 is pi by 2. So that comes out root 2 pi. This is the answer. So I would like to leave this example for you. 0 to pi by 2 root 10x minus root cot x dx. In this case, up to this stage as it is, So here you get the minus sign. Clear? Now is the derivative of sin x plus cos x. So this root 2 sin x, see, Here it is arranged in this way because derivative we want sin x minus cos x. So in this case, this can be written as 1 plus 2 sin x cos x minus 1. Yes or no? Then here is a combination of sin x plus cos x whole square. And take that is equal to t. This is the change. Whenever here plus sign is there, then arrange in this way. Whenever here minus sign is there, then arrange in this way. 1 plus 2 sin x cos x minus 1. It's very easy. So once again, let us leave for you. Next one, let us see. 2 to 3. 2 minus x over under root 5x minus 6 minus x square dx. Linear over square root of quadratic. Arrange derivative here. Clear? So I am leaving for you. Now 1 to 2 dx over x into 1 plus log x whole square. In this case, take log x is equal to t, then it is very easy for you. Next one, pi by 6 to pi by 2. Cosec x cot x over 1 plus cosec square x dx. Convert into sin cos, then rest of part very easy. So I am leaving, once again I am leaving for you. 0 to pi by 2 root sin x into cos raised to 5x dx. So can I write here 0 to pi by 2 root sin x into 1 minus sin square x whole square into cos x dx. This comes out cos raised to 4 into cos x dx. Now you can take sin x is equal to t. So let us leave once again that for you. Here see. 1 to 2 dx over x plus 1 into under root of x square minus 1 is given. Clear? So let us see the interesting sum. So let us see on next page. See. So let us take that important example. Integral 1 to 2 dx over x plus 1 under root of x square minus 1. That is equal to, can I write 1 to 2 dx over x plus 1, two factors, root x plus 1, root x minus 1. So 1 to 2 dx over x minus 1 raised to half x plus 1 raised to 3 by 2. Now see here. Power, here power of x plus 1 is 3 by 2, here 1 by 2. See, this one is important step. 1 to 2. Can I write here? X minus 1 raised to half over x plus 1 raised to half into x plus 1 raised to 3 by 2 into x plus 1 raised to 1 by 2. Multiplying, dividing it. So that is equal to 1 to 2 dx over root of x minus 1 over x plus 1 into x plus 1 whole square. 3 by 2 plus 1 by 2. That comes out 4 by 2, that is 2. Clear? Now suppose root is equal to t. Suppose whole root x minus 1 over x plus 1 is equal to t. See? Direct you can differentiate it also. Root something 1 upon 2 root something into derivative of x minus 1 over x plus 1, use division rule. Denominator quantity is the numerator, derivative of denominator quantity, numerator numerator as it is derivative denominator quantity into dx is equal to dt. So 1 upon 2 under root x minus 1 over x plus 1. Here it comes out 2. Yes or no? 2 over x plus 1 whole square dx is equal to dt. 2 get cancelled. 1 over 2 under root x minus 1 over x plus 1 into x plus 1 whole square dx is equal to dt. See, all this term is converted into dt. So what is I? Sorry. Also we need to change the limit also. Also x tends to 1 implies first of all t tends to 0. Why? X is equal to 1 here, then 0. X is equal tends to 2. T tends to. X is equal to 2 minus 1. 1 plus 1. T tends to 1 upon root 2. So I is equal to limit 1 to 2, so 0 to 1 upon root 2. 0 to 1 upon root 2. Next, whole this quantity. Whole this quantity is equal to dt, and that is here, see. So just that is equal to dt. So that is equal to t, 0 to 1 upon root 2. So 1 upon root 2 minus 0, that comes out 1 upon root 2. So this one is important for us. See, they can take any linear factor here, any linear factor here, but one of factor of this combination is this one. Cube root, fifth root, likewise we are going to arrange it. See, convert into this type of powers. Then see which one have a greater power. So 3 by 2, x plus 1 a greater power. So divide by x plus 1 raised to half and multiplied by x plus 1 raised to half. Okay? Yes. Now see, let us see some example. 0 to 1, tan inverse x upon 1 plus x square into tx. Very easy. How to solve this one? I is equal to this one. Can I write 0 to 1 tan inverse x into d by dx of tan inverse x? Yes, its derivative is here. So that is equal to tan inverse x whole square by 2, 0 to 1. So 1 by 2 common, tan inverse 1 whole square minus tan inverse 0 whole square, 1 by 2, pi by 4 whole square, pi square by 32. Yes or no? Yes. Say let us take 0 to 1 x over x square plus 1 dx. What we have to do? That is equal to 1 by 2 multiplied and divided by 2. Why? Because its derivative. So can I write that is equal to 1 by 2, 0 to 1, x square plus 1, d by dx of x square plus 1 into dx. 1 by 2 log mod x square plus 1, 0 to 1. 1 by 2 log 2 minus log 1. So 1 by 2 log 2 base e, or in other words you can write log root 2 base e also. Clear? Next one. I is equal to 0 to pi by 2 root sine phi cos raised to phi phi into d phi. what we have to do? Now see, very easy. 0 to pi by 2 under root sine phi. Can I write here? 1 minus sine square phi whole square into cos phi d phi. Converting into that form. Now take sine phi is equal to root sine phi is equal to t. Suppose root sine phi is equal to t. So sine phi is equal to t square. So cos phi d phi is equal to 2t dt. Yes or no? Yes. Also, phi tends to 0. Imply t tends to 0. And phi tends to pi by 2. Implies t tends to 1. Sin pi by 2 is 1. So what is I? I is equal to 0 to 1. This is t. Under root 1 minus sin phi is equal to t. So sin square is equal to t raised to 4 whole square into cos phi d phi is equal to dt. Agree with me? Yes. That is equal to 0 to 1, 1 minus 2t raised to 4 plus t raised to 8 dt. So that is equal to 0 to 1, t raised to 9 minus 2t raised to 5 plus t into dt. T raised to 10 by 10 minus 2t raised to 6 by 6 plus t square by 2, 0 to 1. So 1 by 10 minus 1 by 3 plus 1 by 2. So let us consider 30 LCM, here 3, here 10, here 15. So what you get? 8 by 30. 4 to the 8, 15 to the 30. Yes, this is the answer. Clear? In next one, see, I is equal to 0 to 1 sin inverse 2x over 1 plus x square. See, let us see two more examples. 0 to 1 cos inverse 1 minus x square over 1 plus x square dx, or 0 to 1 tan inverse 2x over 1 minus x square dx. All these three are of the same pattern. So I am liking to take this one here. Now see, 2t over 1 plus t square, 1 minus t square over 1 plus t square, 2t over 1 minus t square is a formula of sin 2 theta, 2 tan 2 theta, cos 2 theta and tan 2 theta. So let us suppose x is equal to tan theta. X is equal to tan theta. So what is dx? Sec square theta d theta. Yes or no? Yes. And if x tends to 0 implies theta tends to 0. And x tends to 1 implies theta tends to pi by 4. Why? Tan pi by 4 is 1. And therefore, I is equal to 0 to pi by 4 sin inverse 2 tan theta upon 1 plus tan square theta into sec square theta d theta. 0 to pi by 4 sin inverse sin 2 theta into sec square theta d theta. So that is equal to 0 to pi by 4 2 theta sec square theta d theta. Now by integration by parts. 2 theta as it is, integral of sec square theta d theta, limit 0 to pi by 4 minus integral 0 to pi by 4 d by d theta of 2 theta, integral sec square theta d theta as it is, whole into d theta. So that comes out 2 theta tan theta. Agree with me? Yes. 0 to pi by 4 What is derivative of 2 theta? 2, and this is tan theta d theta. So 2 pi by 4. 2 into pi by 4 into 1. 0 then 0. Minus 2 outside. 0 to pi by 4 tan theta into d theta. That comes out pi by 2 minus 2 log mod sec theta. 0 to pi by 4. Now that is equal to, see, that is equal to pi by 2 minus 2 log sec pi by 4, that is log root 2, sec 0 is log 1, log 1. So pi by 2 minus 2 log 2 root 2 base e. Can I write here? Pi by 2 minus log 2 base e? Yes, root 2 whole square. And this is the answer. This is the answer of this question. On same line, homework. On same line, homework. Next one. I is equal to 0 to pi by 2 sin x over 1 plus cos square x dx. Very simple, so I am not going to solve it, but I would like to just give hint to you. Take cos x is equal to t. Why? Because its derivative is here. Next one, I is equal to dx over x plus 4 minus x square, 0 to 2. See here, how to solve this one? Arrange denominator quantity is quadratic form. So first of all, arrange it x plus 4 minus x square. Can I write minus of x square minus x minus 4? Minus of x square minus 2x into 1 by 2 plus 1 by 4 minus 1 by 4 minus 4. That is equal to x minus half whole square minus 17 by 4. So that is equal to 17 by 4 minus x minus half whole square. So that is equal to I is equal to 0 to 2 dx over root 17 by 2 whole square minus x minus half whole square. That is equal to 1 by 2a. 1 by 2a log mod variable plus constant over variable minus constant, upper limit and lower limit, 0 to 2. Clear? So this comes out 1 by root 17. First of all, simplify it. 2x minus 1 plus root 17. 2x minus 1 minus root 17, 0 to 1. Sorry, 2. To 2. 2x, yes. 1 upon root 17. Take x is equal to 2. 2 to the 4. 4 minus 1. 3 plus root 17. 2 to the 4 minus 1. 3 minus root 17. Minus. Take 0. X is equal to 0. Log mod. Root 17 minus 1. Root 17 minus root 17 minus 1. 1 by root 17 log 3 plus root 17 whole square. No, as it is. Here also we can write in this way. Root 17 plus 3 over root 17 minus 3 also. Why? Because magnitude sign is there. Minus log under root 17 minus 1 under root 17 plus 1. Clear? In this way. Now you can rationalize it also. 1 upon root 17 log root 17 plus 3 whole square over 17 minus 9 minus log root 17 minus 1 whole square over 17 minus 1. That is equal to 1 by root 17 into bracket log. See, whole square is there. So take it 2 outside. 2 log root 17 plus 3 upon 17 minus 9, 8 over 8 over 8 minus 2 log root 17 minus 1 over 16 over 16. So 2 is outside, 2 under root 17 log root 17 plus 3 by 8 over 16 by root 17 minus 1. That is equal to 2 by root 17 log 2 under root 17 plus 3 over under root 17 minus 1 also. Once again you can simplify it also. 2 by root 17 log mod 2 root 17 plus 3 into root 17 plus 1 upon 17 minus 1 also. That is 2 by root 17 log, here we get 16. Now you can simplify it, write it here. This is the answer. Clear? Next, I is equal to minus 1 to 1 dx over x square plus 2x plus 5. I am leaving directly for you. Arrange it into perfect square. Likewise, x square plus 2x plus 1 plus 4. That is x plus 1 whole square plus 2 square. Rest of part very easy, so I am leaving for you. Next one, I is equal to 1 to 2 e raised to 2x 1 by x minus 1 by 2x square into tx. See here. Here also we have to see interesting sum. See, if we apply this formula, here should be x, other than x, whatever may be. If we want to apply this formula, in that case here should be only one variable, not any constant also. So here we have to take 2x is equal to t, substitution. Suppose 2x is equal to t. So x is equal to t by 2. So dx is equal to 1 by 2 dt. Also, x tends to 0 implies t tends to 0. X tends to 0 implies t tends to 0. And x tends to 2 implies t tends to 4. Yes or no? Yes. And therefore, I is equal to 0 to 2, 0 to 4. E raised to t, 1 by x. X is equal to, that is 2 by t. Yes or no? Yes. Minus 1 by 2 into x square. X square means t square by 4 into dt. 0 to 4 e raised to t 2 by t minus 2 by t square into dt. 2 is taken outside, 0 to 4 e raised to t 1 by t minus 1 by t square. That is derivative of 1 by t into dt. So 2 e raised to t by t, 0 to 4, 2. If you take 0 to 4, 1 minute, 2x is equal to 1, sorry. T, x tends to 1 here, x tends to 1. So t tends to 2, t tends to 2. So 2 to 4, 2 to 4. Why we get this type of somewhere mistake is there? Because here dt is there. So 2 to 4, 2 to 4. Well, first of all 4. E raised to 4 by 4 minus e square by 2. Now 1 by 2 is taken common, that get cancelled. E raised to 4 by 2 minus e square. E square by 2 is taken common. E square minus 2. This is the answer. Clear? Yes. Next one. I would like to see this example. minus 1 to 1 5x raised to 4 under root x raised to 5 plus 1 dx, very easy. Take x square is equal x raised to 5 is equal to t. Can you get the dt rest of part? Now this is the end of exercise 7.10. Clear? Now up to 7.2 exercise, all possibility of definite integral with help of substitution we seen. In next lecture we are going to see some basic results of definite integration and some based on that part. In last board exam, 4 marks sum is asked by this one, root 3 10x. That means this example asked from indefinite integration. Now most probably in 2021, 4 marks sum based on definite integration. Clear? I hope so.